Hi, geometry, welcome. We're looking at our Saxon geometry book and we're jumping into lesson 40. So this week we're covering lessons 40 through 43. Now, we spent some time in class going over these, but I just wanted to take a few moments just to put this out there in case you had questions at home or in case that you might need a little extra practice or review at home. So lesson 40 starts with finding perimeters and areas of composite figures. So what's really fun about these shapes is you're just breaking down. And your book even shows you on the bottom of page 257, it's showing you that if I take one shape and I'm looking for the whole area, then I'm just breaking down each of those parts. As long as they're not overlapping, you would never want to make one area count double, right? So if I have a shape and I can take this part and then this part, add it together. It's the whole. So the book is just explaining that on page 257. All right, and they have some good pictures on the top there about it's a triangle and a rectangle, so you can solve each separately and then put them together. Now, they've given us some neat shapes. We've got multiple triangles and rectangles. So there's a lot of different opportunities there to just use the different shapes and put them together. Now on page 259, example 4, it shows us an application in architecture. And it shows you a pool that's a very interesting shape. It could be easily noted that it would be a rectangle all the way around. But then notice there are little rectangles in each side that have altered the shape of it. Well, it says the edge of the pool needs to be tiled. What is the perimeter? So you have to go through and kind of think through what would be the edge of the pool, not just the shapes that you see. So it's a lot of reasoning there and thinking through. So they've showed you the solution. So I think that's important that you all take time to look over those. Now the lesson practice just breaks down some of those things for us on page 259. And it shows us even the examples that it's following. So you've got one question for each example and then two for example 4. So if you'll look at letter B, it says determine the area of the figure. Express your answer in terms of pi. So it's very easy to find the area of the square, and you can see that there because it shows us that all the sides are the same and all the angles are right angles. So we know it has to be a square. So the part of that square that's super easy to find, side squared, it would just be 4 squared, which would be 16 centimeters squared. Now the hard part is going to be finding the half circle. So we know that the area of a circle is pi r squared. Well, if we know that the diameter is 4, then the radius is 2. So it would be 2 squared, but please remember that it's just a half circle, so you've got to take half of that. So your final answer, you don't have to multiply through by pi, just put it in terms of pi. So that's all that you're doing in that lesson, is just breaking down parts and adding those parts together. Now, I would encourage you to take some time on page 263 to look over the triangles. And your book calls it the hinge concept, where the wider you swing a door, then the more area that the distance between the door and the frame, the wider you swing it. And that's an interesting concept because it's important for us to remember that depending on how big this angle is directly impacts how big this opposite side is. But if I have a very small angle, then this side is going to be a lot more small. So the book is kind of showing you that you could even go itty bitty, couldn't you? And so obviously this angle is very small, so that side's going to be very small. So that's what they're kind of teaching there in that investigation. So I wanted to point that out to you so you were thinking through that hinge theorem. The opposite side directly relates to the size of the angle opposite it. And then on page 264, they show pictures of a stick figure to show his posture and how it relates to the distance between his chin and his knee. So pretty interesting idea. Now, lesson 41 is just ratios, proportions, and similarity. We understand that if a triangle is not the same size, but it is the same shape, then their ratios are the same. And what that means is that their angles are all the same, just their size is not the same. So the ratios. So the book is showing you there how to set up ratios. Don't forget, it talks about the means and extremes and the cross products. So that's very important there, the means, the extremes, and the cross products on page 266. And then they give you some examples of setting up those ratios. And that's very important as you're solving those. And then they've given you different shapes that are similar and reminded you to set up those ratios. So on your practice, it says write a ratio comparing the lengths of HA to AM. So you're just going to set up those ratios and solve them. And that's all that you're doing on those. So you've got several example problems. And I want to point out to you how important it is that order always matters. So if you're doing the small triangle first, do the small triangle first in the next one. So make sure that ratio is always the same. So I think you'll do great on that. We've done ratios before. You've done it in Algebra 1. So I think you'll do great. Now, lesson 42 is finding the distance from a point to a line. And there's several theorems that they talk about. If you have a point outside of the line, then the fastest way to get there is a straight line, right? One straight line is the quickest way there. Now, don't forget your distance formula. That's on the bottom of page 274, and I would encourage you to commit that to memory. The distance formula has roots in the Pythagorean theorem. So just like a squared plus b squared equals c squared, well, that's how we help find the distance formula. So your book is going over that in this in this lesson. So all you're going to be doing in the lesson practice is just finding the distance between the line and that point. And I would encourage you, make sure that you're looking over your examples. And example 2 shows you on a number line and shows you how to use those. So we've done that before, and I think you all will do a great job with those. So that's all that you're covering in lesson 42. All right, and then lesson 43 is a little bit more terms. So we've covered a lot of terms this week. So we're looking at chords, secants, and tangents. So your book gives you those definitions in blue, and I would encourage you to look on page 43. So a chord is not a diameter because it does not have to go through the center point. So it just touches one side of the circle to another, and it does not have to go through the center point. That's what makes it a chord. A secant goes a line that goes through it and passes through 2 times. A tangent, or a line of tangency, it touches the circle only once. So it will not go multiple times through it. So you just kind of think of it sitting on that edge. So that's what tangent means, right? Point of tangency. And that is on page 281. So I would encourage you to take a look there and kind of refresh yourself with that terminology. There are several theorems in lesson 43. And then it gives you some application of plumbing and just different neat concepts. So take some time to pause this and read through those. You know, your formulas sure do, your book and those examples and those theorems really do help. Now look on your lesson practice. It's on page 284. It says identify each line or segment that intersects the circle. So you understand that FHG would be the diameter because it goes through the center. But if you look at line L, excuse me, I am so sorry for yawning. Please know that geometry is not boring. It's just late in the evening here, so I'm not sure if you can tell that. But line L actually goes through the circle 2 times. So it can't be a tangent since it goes through twice. It has to be a secant, right? All right, and then line M would be a line that is tangent. So the point of tangency there is that one dot where it touches, but line M is a tangent. All right, now it asks you to find the value of A. Well, we know that if it is a chord that passes through and it's at 90 degrees, then we know A has to equal 7, right? So that's very, very important there since it's a straight line. And it's at 90 degrees. So that's what gives us that. All right, I'll let you work on the rest of those, but there's some neat diagrams, but don't forget also that there are other examples. So I think you all are doing great. I'm really proud of your hard work in geometry, and I look forward to seeing you next week for 4 more lessons. God bless. Have a great week.